Hey everyone, welcome to today's video. I'm going to be going over lesson 5.2, which talks about exponential equations. Okay, again, normally I don't go through the bell work, but this one has some nice examples that prepare you for today's lesson, so I wanted to go through those. We're going to go ahead and skip straight to number 5 right here. So on number 5, it is saying that they would like us to use the equation y equals 3 to the x power to complete the table. So to do that, all we need to do is we need to plug these numbers in for our x, so you get like y equals 3 to the 0 power. Remember, anything raised to the 0 power is just equal to 1. Okay, then you'd plug in 1, you'd get 3 to the first power. Anything to the first power is just itself, so we get 3. Okay, then we would do 3 squared, which is 3 times 3, or 9. And you can use your calculator for these as well. You just keep plugging these in. So some of you know this already, but in case you didn't, how you would do this, sorry, my calculator's on something else. You would type in 3, and to change which exponent you're raising it to, you can use this button right here. It's called a caret key, and that will raise it to a power, and I want to type into the third power to get 27. And then I would do 3 to the fourth power to get 81. Okay, so that's how we would do those. So looking at this, they want to know if this equation is linear. Remember, if it's linear, it's going to have an addition pattern. We can see we're going from 1 to 3 to 9 to 27 to 20 or to 81. So we're not adding a constant amount each time, so it won't be linear. But we do see that it has a pattern, so it's not linear. But the pattern, we can see it is multiplying by 3 each time. Okay, so you can say something to that effect. Same idea on this next one. They're saying to use the equation y equals 2x to complete the table. So if we go to our calculator here, it would be 2 to the 0 power, which gives me 1. To the first power, which gives me 2. I'll get 4. I'm just going to kind of go through this quickly. 8, 16, you can keep typing those in. So we can see again this is not linear, but it is doubling every time or multiplying by 2. So there's a pattern there. So the next question asked you, without filling in a table, what do you predict the pattern will be for the y values if the equation is y equals 5 to the x power? Okay, this one was multiplying by 2, this one was multiplying by 3, so does it make sense that this one would be multiplying by 5? For our pattern. Okay. So we are going to learn a little bit more about those equations right here. So today's lesson is on exponential functions, and by the end of today you should be able to recognize and graph an exponential function. So an exponential function, it's our only word, but see how much information there is about this. Okay, this is going to tell you everything you need to know. It says a nonlinear function of the form, and this is the formula, you're going to need to know it, y equals a times b to the x power, abx. Let me zoom in a little bit. Okay, where a cannot equal 0 and b cannot equal 0, and b is greater than 0. So let's talk about what these mean. So if a equaled 0, we'd get 0 times all this. This whole thing would equal 0 and we'd have no equation. Same if b equaled 0. Remember, if we times anything by 0, it goes away. So we don't want our formula to go away, so that's why a and b can't equal 0. And we want b to be greater than 0. What that means is it can be any number bigger than 0. The type of numbers that are bigger than 0 are positive. B has to be a positive number in order for this to work. If it's negative, it'll have a pattern. Okay, it would even form like a geometric sequence like we saw in 5.1, but it's not going to be exponential. And we can talk about why here in just a little bit. Okay, also with exponential functions, as x increases by a constant amount, so x is just going to go up normal. 1, 2, 3, 4, so on and so forth, y is multiplied by a common ratio. So like we saw in our bell work, as x went up, y was multiplying by 2 each time, or by 3, or by 5. Okay, so it's going to go up by a common ratio. Okay, the a value is the y-intercept. So right here, the first number that you see when they give you your function will be your y-intercept. And the b value is the common ratio. So that's your ratio or your r value, okay, for the pattern for your y values. Okay, and your graph will always be curved. It'll look something like this. I mean, it can go different directions and stuff. It'll have some curve to it. And then this part got cut off on our notes, I'm sorry, but it said, remember, any number raised to the 0 power is 1. Okay, so if I raise 2 to the 0 power, it equals 1. It doesn't matter what number. If I raise it to a power of 0 and have an exponent of 0, it's going to equal 1. Okay, so that's what that last little note there was. So looking at these next 6 questions here, they're asking you to determine whether the equation represents an exponential function or not. Okay, so it's got to match this formula right up here, and there will be some ways that they try and trick you a little bit. We'll talk about those too. So on this first one, do I have a number times another number raised to an x power? No, we can see this would actually be a linear equation. Okay, so this is not exponential. On number 2, we can see that this one is exponential. We have our a value of 2, our b value of 3, raised to the x power, so yes, this one would be an exponential function. Okay, number 3 tries to trick you. Okay, we have some number raised to an x, so we've got our b raised to the x power. They don't write a letter a in here, or a number for a, but whenever it's not included, okay, it's really just a 1, we just can't see it. Okay, so we now have a times b to the x, so it looks like it might be exponential, but what do we remember about b? B has to be greater than 0, or b has to be positive. Okay, b is not positive on this one, it's negative, so no, this is not exponential. Okay, the reason is if we multiply by a -2 each time, and I had a paper where I'd written this down earlier, let's see if I can find it. Okay, what happens on that is if I raise this to the 0 power, and you don't need to understand the why, this is just in case you're curious. Okay, our first number would give us a 1, then a -2, then a +4, then a -8. See how it's switching? Positive, negative, positive, negative. When you go to graph it, it's going to start to do something like this, so it's not exponential. It has a different pattern. Okay, so you don't need to memorize this. Just know that it can't be negative inside of there. Okay, so then you're going to look at number 4 and say, oh, this one's not exponential either. But guess what? They tricked you again. On this one, do you see how this one had the -2 in the parentheses and this one doesn't? When it's not in parentheses, there's a special little trick here. They're saying this is really -1 times 6 raised to the x power. On this one, my a value is negative instead of my b value. So yes, this one would be exponential. The reason for that, okay, is when we have this, remember our order of operations. Okay, please excuse my dear Aunt Sally. Some of you learned at GEMDOS, okay, lots of different, or PEMDOS. Depends on the teacher and the way that they taught it. But we can see that exponents comes before multiplying. Okay, so what this formula tries to do is it tries to raise the 6 to the power and then times it by the negative right there, the -1. And we can see that on our calculator. Do, in parentheses, -6 squared. Okay, that says I'm squaring the actual -6. But if I type it in like this, whoops, I got that twice. See how it switches? It squares the 6 and then adds the negative. So just know if it's in parentheses, it's a -6. If it's out of parentheses, it's technically a +6 multiplying by a -1. You won't see very many of these, so if you don't fully understand that yet, that's okay. but just know that there's a difference there. And that's why whenever you're typing this into your calculator, I say put it in parentheses or it'll do it wrong, okay? So number 4 would be yes. Okay, they get a little bit easier from here. So let's look at number 5. We have two numbers, they're both positive, raised to an x, so yes, this one is exponential. Okay, this looks like it has an a value, but do you see how they switched these? Put x down there and the number up here. Okay, that one is not exponential. It's still a type of function, it's just not an exponential one. Okay, they do get easier from here, I promise. Okay, on these next ones we're going to be determining if it's a function or not, and if it is, they want us to find the common ratio, and we're just going to use the table. So remember, right up here they give us a clue. Okay, and they're saying as x increases by a constant amount, so x is just counting up, y is multiplied by a common ratio, or by the same number each time. So let's look at first one. My x's are counting 1, 2, 3, 4. They're doing what they're supposed to. Okay, my y values, are they multiplying by the same number over and over? 3 times 3 gets me 9. 9 times 3 gets me 27, and 27 times 3 gets me 81. So yes, this one is exponential, and my common ratio is the 3 that I multiplied by. Okay, again, if you're not sure how to figure out the multiplication, you can do the second term divided by the first one. I'll say it's multiplying by 3. Whoops, you can't see that. So then you could just do 3 times 3 to get your 9, times that by 3, so you get the 27, times 3 gives you the 81. Okay, on number 2, my x's are counting, those are good. My y's, okay, I'm going from 4 to 6, 6 to 8, 8 to 10, there's a pattern there, but do you see how it's adding to each time instead of multiplying by a number? Okay, so that's not exponential. It's arithmetic, and it would have a common difference of 2, but that's not what we're looking for. Number 9, same idea. 1, 2, 3, 4. Those are doing what they need to. 5 to 2, I subtracted 3. Subtract 3, subtract 3. So again, it has a pattern, but not a multiplying pattern. So no, it's not exponential. And number 10, 1, 2, 3, 4. Those are good. 24 down to 12. Subtracted 12, or I times by a half, divided by 2. 6 is half of 12, 3 is half of 6. So yes, it has a constant pattern on this one. So yes, this one's exponential, and our ratio is 1/2. Again, if you're not sure, you can do the second divided by the first. 0.5 is the same as saying 1/2. Okay, and you could do that for each of these, and you'd find that it works out like that. Okay. On 11 through 14, what they're asking you to do is evaluate this function for the given value of x. So all that means is plug in the number that they give you for x and solve. That's what evaluate means to do, is to solve. So y equals 2 times 4 to the negative 2 power, and if I type that into my calculator, I'm going to zoom out a little so you can see the buttons I'm pushing. 2 times 4, I hit this button right here, and I type in negative 2. That gives me 1/8, so that would be my answer for my first one. For my second one, I'm plugging in 3 for my x right there. Zoom back in so you can see that, so it'll be kind of big on the calculator, but you can see. Negative 3 times 5. Press our exponent button, and I'm raising it to the 3rd power, which gives us negative 375, so on and so forth here. So y is going to equal 1.2 to the 2nd power, which gives us 1.44, and let's see, we have 1/2 times 8 to the, whoops, wrong button there. Sorry, I typed that in wrong. to the negative 2. Oh, you guys can't even see that, sorry. To the negative 2. Which gives us 1 over 128. So again, just knowing how to plug that in. So this is going in place of x, which is our exponent. And this button right here, it kind of looks like a little tent. Okay, that's the button that allows you to do that on your calculator. Okay, number 15. What they're asking us to do here is to use the following functions to find the y-intercept and the common ratio. So remember, I said right here, the first number, our a value, is our y-intercept, and the second number is our common ratio. So this printed kind of funny. This should be number 19 right here, the second one. See, it just wrapped over to the line, so let's rewrite that over here. F of x equals 3 with the 1/4 to the x. Okay, that'll be number 19 over there. It just printed out wrong. Okay, number 15 gives us a 4 where our a value is. So that was our y-intercept. And a 2 where our b value was, so that gives us a 2. That's all we're doing. On this one, the 1/2 is in the parentheses, it's being raised to the power, that's our common ratio, but they didn't give us a number in front. Remember, it can't be 0, a can never equal 0. We said if we can't see it, it's an imaginary 1 right there. Okay, because 1 times anything is just what that something was, so it just is simplified to not write the 1 in there. Same idea on this one. The 5 is what's being raised to the power, so that's our common ratio. And it would really be like if we had 1 times 5 to the x, because the 1 doesn't change anything, so we just simplify it to 5x. Okay, these didn't line up very well, but this would be the answer for 18. Okay, number in front is negative 2. Is it okay to have that negative? Yes, because it's the a value, okay? The number inside of here, our b value is positive, and it's positive 1/2, so that one looks good. And then 19 that we had to rewrite, number in front is 3, and the ratio was 1/4. Hopefully those are pretty easy. Go ahead and turn the page here. On these we're doing the same thing, but now we need to graph them. So we can see that our y-intercept here is positive 2. Our common ratio is 3. And to set up our tables, we get to choose what our x values are, but I'm going to tell you it's going to be easiest if you just do like 0 through 4 for each of these. Okay, and to find our y values, we're just plugging our x values into our equation right here. Okay, if we plug in 0, 3 to the 0 power becomes 1. 2 times 1 is just 2. And that's what we expected. We knew our y-intercept was 2, and our y-intercept happens when x equals 0. Okay, we could plug each of these x values in, but I'm going to show you a shortcut. Remember this from Unit 4, we can do our table. If we press table, I'm going to clear that out, we can just type in this equation. So to do that, we had 2 times the 3 to the x power. So I hit the exponent button right here. And remember, to get the x, it's this button right here with all the letters on it next to the 4. We press that, and it's typed in my equation just like it was on my page. I think I need to turn the light off for this to show up a little better on the calculator. Okay. So now what we do is we press enter, scroll down till you have the word OK highlighted, and press enter again. And it'll give you this table. So now all you have to do is find the x value. So we started at 0. It gave us 2. At 1 we have the number 6. Okay, when x is equal to 2. So all this is doing is this table went ahead and it plugged all these numbers in for x for you so that you don't have to type it in a whole bunch of times. So that gives us 18, 54. I'm not going to scroll through the calculator. Okay, so we see we get the 54 and the 162. Okay. So we can see there's a pattern here. It is multiplying by 3 each time, which is what we expected because that's our common ratio. It says start at 2 and multiply by 3 each time, which is exactly what happened with our y values. To graph that, we come over here and you can see they're counting by tens, so it makes it kind of tricky to graph some of these numbers, but you just need to do your best approximation. So when x is 0, we're right here on this axis, we're at 2, so that's going to be a dot just above my line right there. And you could label this point 0, 2, okay? Then our next one, at when x is 1, I know that y is 6, that's about halfway up. You could label each of these, but you don't have to. When x is 2, my y value is 18, which is right about here. When x is 3, y is 54, which is right about here. And when x is 4, y is 162, so it comes all the way up right here. And that's what gives, and then we connect our dots. That's what gives our line this nice curve, okay? Because we go up from 2 to 6, and we times that by 3, and we keep timesing by 3, so the amount we go up each time is growing, and it's growing quickly, so that's why it gets steeper and steeper. Okay, same idea on this next one. Let's do 0 through 4 for our x values. So we're just going to press clear. Don't ever change the settings on these, just scroll down to the OK button, okay? Otherwise it will mess things up. So we pressed the table button. I can clear out the function that's in there, and this time I'm going to type in this equation. So I have 8, and in the parentheses I have the fraction 1/2 raised to, so I'm pressing this button, and then my x. Okay, I press enter. I don't change any of the settings, I just scroll down to OK, and I press enter again, okay? So, oh, and I forgot, we need to answer a couple questions over here. We know that our y-intercept is 8, so that's our starting point here at 0. Our common ratio is 1/2, so it should be multiplying by half each time. We could actually probably figure that out and then use our table to double check it. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is 1/2. Do you see that? And those should be the same numbers we get on our calculator. At 0, we have a y value of 8. At 1, we have a y value of 4. 2 and 2. 3 and 1. And at 4, we have 1/2. So our table is working. Okay, to graph these, same idea as what we did before. When x is 0, we're up here at 8. When x is 1, we're at 4. Then at 2. Then at 1, so just halfway up here. Okay, and we can see that curve. So, is this ever going to equal 0? Okay, it's not. We're just going to keep cutting in half. Can you ever cut something in half and have it equal nothing? No, it's going to get really close to 0. We're going to get really small fractions. But it's just going to keep getting smaller and smaller and smaller. Okay, so it would kind of level out like this along with 0. Okay, next one. So remember, if it's not doesn't have an extra number in front, then your y-intercept is 1. Common ratio is 2 because that's the one that has the x on it. I have to make a space there because the hole punch is right there, sorry. So this is the one where we'd want to use our table. Okay, so our equation is just 2 to the x power. Press OK, scroll up. So we can see that when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. And it should just be doubling each time. 1, 2, 4, 8, 16. We could even do the fifth one because it goes out to 5 over here. 16 times 2 is 32. Okay. So then over here at 0 we were up 1, which is just part of the way up. At 1 we're at 2, then 4, then 8, then 16, then 32. And we start to see that curve right there. And you can see that I would level out like that as well. Okay, this next one came out a little bit tricky. Our y-intercept is -4 and it's cutting in half each time. So So we're starting at -4. We can use our table, but we also know half of -4 is -2. Half of that is -1. -1 half. Half of a half is a fourth. Okay. So to graph these, we can see we're at 0 and 4. Okay, they give you kind of a big scale here, but you can still figure it out. On your first one, you're at -2, -1, half, quarter. So this is really tiny, but you can see it's getting closer to 0, but not equal to it. Okay. Okay, same idea on these next two. I'll go ahead and skip those. Already at 25 minutes here on the video, so you would be able to graph those by making your tables. If you still have questions on this, I'm happy to answer your questions. Just make sure you come in and talk to me. Have a good day.